Hey, this is Mr. Bryant. I'm posting this on YouTube because the Screencastify thing wasn't happening. So hopefully you're able to view this okay. Please feel free to send me any questions on Dojo or through Google Classroom, and I'll be glad to answer those. Remember, if you turn this in, you'll get 100 as a daily grade. If you don't turn it in, I'm not going to include that in the grade book, but everybody that turns it in will get an additional grade of 100 for a daily grade thing. Okay, number 1. Justin uses a container in the shape of a cylinder to store his markers. The diagram below shows the dimensions of the container. For any question that involves circles, we always begin with R equals D equals. Which one do they give us here?
They gave us the
diameter.
They give us the diameter, which means we divide it by 2 and we get our radius.
7.
7. The height is 20. So the reason we always want to do D equals R equals, this is a very good example because in our equation, volume equals area of the base times height. So maybe I'm thinking about that song. Back to life, back to the area. So we use the area equation instead of capital B, pi r squared. The area equation requires radius, which they did not give us. That's why we calculate this at the beginning. Now we have the the radius, and we're able to put everything in there and calculate. 3.14 times 7 squared times 20. When we calculate all that, we get around 3,077. A.
Yeah.
Well, that's not what you get. 0.2, but okay.
Approximately.
Approximately check.
Okay.
Sure.
Yeah, check.
You gotta learn how to do wrong sometimes.
Number 2.
Holy moly.
For storage, Mrs. Lynn uses cylindrical containers like the ones shown below. Cylindrical means cylinder. If Mrs. Lynn uses 2 of these containers, which is closest to the total volume of both containers? Keyword there?
Both.
Both. Very good.
Both containers.
So we're talking about volume. Again, here's our equation. Both means we're going to do what?
You got a call.
What are we going to do when it says both? What does that mean?
Like both.
Mathematically.
Add.
No, multiply by 2.
Multiply by 2. So we're going to do, at the very end of everything, times 2.
Get it,
So we use back to life, back to the area.
Yeah.
Pi r squared times height, and then times 2. So we use 3.14 times 1. I'm sorry, we didn't do this. We didn't do r equals d equals.
We messed
R
up.
equals 1, diameter equals 2,
Two.
height equals 2. So now we have all of our information. 1 squared, r squared, 1 squared times height is 2, and then both times 2. We calculate all that, and we get 12.56, which is closest to 13 feet.
We're doing rounding now.
Closest.
Because it's 12.5.
So if we forgot the both part, we would have calculated 6.28.
Mm-hmm.
Guess what one of our answer choices is? 6. But you have to catch what they're asking. Both.
Mm-hmm.
Sometimes they may ask you for like a couple of containers, and they may say, what is the difference? What does difference mean?
Like a difference.
Over here.
Subtraction.
Difference. Okay? So we have to be very careful in reading so they understand what they're asking. Okay. Number 3. This is a challenging problem. There's a lot of information here. In Italy, trulli crowd the narrow streets. A trulla is a small dwelling built from local limestone with stone walls and a conical roof. That's important. Conical, which means we are going to be involved with
Cone.
a cone, right?
Like an ice cream.
The width of the Trula, the width.
True.
What do you think they're describing?
The base.
What about the base?
The
The
area.
width. The width of the base would be what?
The diameter.
Exactly. Very good. So
Yeah.
we look at a Trula,
A true
and it has a width that varies from 0.8. So one of them might be 0.8, and another one might be
0.6.
2.7. 2.7. So, and the height for all of them is 3.3.
On the height. On the height.
Okay? They want us to find the valid statements among 1, 2, 3, and 4. And what I'm going to focus on is the two valid statements are number 2 and number 4. Number 2, it says the maximum volume is 6.3 cubic meters. So we look at the maximum diameter, 2.7 meters. So let's focus on that. So we do R equals and D equals. The width of it represents the diameter from one edge to the other edge, 2.7, which means the radius will be what? 2.7 divided by 2,
1.
which is 1.35.
Yes, sir.
Now we can use our equation. We know the radius, we know what the height is. Our equation is 1/3 times pi times radius, 1.35 squared times 3.3, the height. Calculate all those things and we get 6.3. And that works. We're just plugging in the numbers. We get the information. But we do have to understand the relationships between the width of a circle. They used a different name or a different word, but we understand that across a circle would be the diameter. And from there we can get the radius, which is what we need for our equation. So that's why number 2 works. Number 4, a cylindrical roof with the same width and height as the conical roof. So now they're talking about a cylinder with the same height and the same width, which means the same diameter. So like this, the base of this cylinder and the base of this cone are the same size. That's what they're telling us. They have the same width, they have the same diameter, and the same height. Then the cylindrical roof would have a volume that is 3 times larger, because a cylinder volume is like this, and a cone volume is this. It's the exact same as the cylinder. The cylinder should be like an L. So if we did this, volume equals 12, and over here, that's 1/3 of 12, which would be 4. So the cylinder is 3 times larger than the cone. That's the deal. That's the relationship between those equations. Does anybody have any questions about that? That's what I want you to take away from that. The cylinder is obviously larger than the cone. It would take 3 cones to fill up the cylinder. As long as they have the same diameter and the same height.
Cold.
Alright,
The
number
answer
4.
was. Right.
It's D.
Oh.
He told us. Told us.
Yeah, the answer was 2 and 4, which is D.
I know my Roby.
David has a cone that can contain about 250 cubic centimeters. He wants a cone that can contain about twice as much. Which cone should he choose with the given radius and height? What's the key word or key phrase?
Twice.
Twice as much, which means
Those.
times 2. So you take the container that he has, he wants one, so what do? 250 times 2. And he gets 500. So we need one that has a volume that is equal to 500. Or around, or close to 500. So our volume equations for a cone, volume equals 1/3 times area of the base times height. 1/3. Remember, we want to put that in parentheses. Times pi times, we don't know the radius yet. And we don't know the height. We're going to have to do trial and error with each one of these to figure out which one works. And we can plug in the number 500 for volume. One of these works. So what I want you guys to do is calculate using these radius and height combinations. This row, calculate F. Chad's row, calculate G. Melissa's row, calculate H. Eduardo's row, calculate J. Plug in those values for radius and height, and one of those equations, it will equal close to 5. What's closest to 500? Which one would it be? 1/3, 3.14. What's the radius going to be and the height? What numbers are we going to put in here? Is it working for you guys?
We're working on it.
Did anybody already calculate it and get it? Did it work?
But I'm doing it right now. I'm doing all of them.
Did it equal 500? Okay, so no.
No, it didn't.
So
it didn't.
not F. Did it work for G?
No.
No?
I didn't try G.
Oh.
H? J?
Yeah,
No,
we
no,
went
no, no, no.
JJ.
Look at that.
Jimmy John.
No, go move.
Put in 1/3 in parentheses times 3.14 times radius squared times height. Emily, did you calculate it?
I know which one it is.
Yes.
Yeah.
And this one works.
Yeah.
4 squared times 30.
I did all of them.
It would be like 502.
502.4.
Yeah, this is the answer. Okay,
I calculated all of them.
Instead of hip hop.
number 5.
Nice. How did you change?
Okay, a company has designed a cereal box. I'm going to do my draw a little cereal box.
Ooh, make it Captain Crunch.
You gotta put a box top on it.
Yeah, like a box top so we can recycle it.
There's not no cereal box. Oh, never mind.
That kind of look like a box though.
But it's not a cereal.
Are you sure you're recording, Daniel?
Yeah.
Okay, so
It's orange.
this is kind of a box.
You
The box has a height of 25 centimeters. So I'm going to say this is the bottom here, okay? It's 25 centimeters high. It has a width of 2.5. I'm going to call that 2.5 right here. And then a length of 12.5. Right there. Okay? They want a cardboard used to create these boxes is purchased from a wholesale supplier at a rate of 0.00016 cents per square centimeters. What is the cost to produce each box? Box, we need the surface area, which is perimeter of the base times the height plus 2 times the area of the base. Or, what is the area of the base equation here? It doesn't say area and base, but what two things can we use to find area of the base?
2.5.
Height, width, and length. Which two numbers? Which two things?
Height and
2 times length times width. The area equation. Base times height and length times width are the same thing. When you're just looking at that base. So perimeter is down here. Perimeter of the base. Is it just 2.5 plus 12.5? No, it's all those sides. 2.5 plus 2.5 plus 12.5 plus 12.5. If you add all of those together, you get 30. Do you see where we got 30? We added all of those together. Because that's 2.5 and this is 12.5. Perimeter times the height, which is 25, plus 2 times, and then length times width. 12.5 times 2.5. We calculate all this stuff. This is 750. This is 62.5. Add them together, it equals 812.5. Guess what? What's the key thing? A rate of 0.00016, which means we need to do what? Multiply times 0.0016. I missed a 0. We multiply that, calculate that.
Oh, that is.
What did you get?
5. What? That's not right.
Oh,
Times.
Point 13.
You
Yeah.
get 0.13. If you put in the numbers correctly, you get 0.13. You have to take your time and make sure you're hitting the right numbers, the right number of zeros, and you get 0.13.
I put divided.
No.
Do we understand why we multiplied times 0.00016? Because it was a rate of that. Do we understand how we got 812.5? Each piece, one thing at a time. And then we calculated. Okay. Finally, number 6. Surface area. Which one? Lateral surface area. Which means we don't include the bases. Which is this equation. 2 times pi times radius times height.
Well, not that.
Radius and diameter. Let's see. They give us the radius, which means the diameter is 6. The height is 6. So we can plug all these in now. 2 times 3.14 times 3 times 6. What do I get? 113.04. Which one of these is going to give you that same area? It's not this one because this is just one side. You want the one that's going to equal when you find the area. How do you find the area with these shapes?
Multiply.
Base times height or length times width. Which one will give us 113.04 when you multiply them?
G.
You use base times height and you multiply. Nope, not here. That's too much. That's almost 180. But if you do 6 times 18.85, then you get like 113. right?
Mhm.
That's our answer. All right, good luck.